Okay. Let's see. Oh yeah. So I've actually already gone through the announcements. I'm trying to think if I can rattle them off. Again, we just want to be sure that we're completing our assignments. And Alex, everybody should be doing at least 25 topics per week. If you're at the preparing for intermediate algebra level, then we need to be doing about 35 topics per week. If we're at the preparing for basic math, we need to be doing about 50 topics per week. The goal is so that each student by the end of the semester is at least at the level of preparing for college algebra by the end of the semester. Alex is going to serve as our lab grade. My colleague is going to grade it and send me a weekly report. Um, and and so Alex is going to serve as 10% of our grade. Okay, so we just want to be sure we're keeping up with Alex and getting our assignments on Pearson submitted. Um, if you have not gotten full access, like if you purchase, I know I had one student that purchased material out of the bookstore and the bookstore like ran out and they're just really, really slow about sending things out. You can actually purchase access directly to Pearson and it'll give you instant access and you won't have to wait. But if you're still waiting on stuff from Pearson, then the recommendation, I would just make another account with another email address just so I can keep working. And then once you get your materials, let me know. Yeah, just a regular exam. That's just going to be like exam 2. And then we're going to have a total of 4 exams, I think is how it goes. But it's all on Pearson. It's all via Pearson. Right? Okay. So I think the last thing that we did, we graphed piecewise functions, right? So basically, there was just several graphs on one coordinate plane, and we kept only the part that was pertinent to what we were doing. It should be charged by now. Okay, it's better. It's not fully, but it's good enough. So I'm gonna take you off of this. Okay. And so again, I am monitoring the chat so that if you have a question, we can use that to get my attention. Uh, so yeah, so we're gonna start here. Can I paste? Is it still there? No. Okay. So I got to fix this symbol. The symbol didn't display properly. So that symbol is going to look something like the following. It's called the greatest integer function. And basically, it's x inside a set of square brackets. And then the square brackets have an additional piece like that. Okay. That's the gist of it. Oh. Okay. So again, this is called the greatest integer function. And basically, like if our x is between two integers, then we're just basically going to take the integer to the left. Okay. So I got to fix these guys. Okay. So for instance, so again, you can respond. Feel free to respond to some of these questions in the chat. Like you can use the chat to respond. What's your favorite decimal? What's your favorite decimal? Somebody give me the favorite decimal. Okay. So say we had 2.325, right? If we had 2.325, notice 2.325 is between 2 and 3. So then the greatest integer less than or equal to 2.325 is just going to be 2. All right. So whenever our decimal is between two integers, we just take the integer to the left. If we're on an integer, then we take that integer. Right? That's all that the greatest integer function is. Right? All right. Let's see. So what we're going to be, and it. Stop. Okay. 15. All right. So we're going to go ahead and lock out the meeting. So we're at the 15-minute mark. Okay. This one. So this is just the graph of the greatest integer function. So it's kind of like a floor function. Like every decimal collapses to the integer right below it, and so we call this a step function. And it just basically looks like this. So what we're doing today is building a library of basic functions. These functions are going to serve as like the base for when we start graphing, and we start doing transformations and manipulations and just looking at some graphing techniques. So the first one we have is the constant function. It's like y equals a number. Okay, can somebody tell me the domain of this image? What's the very left to the very right? How far left does the graph go? How far right does the graph go? Feel free to type it into the chat. The very left to the very right. I'll be right back. Anybody? How far left does this graph go? How far right does this graph go? So the very left of this graph, yeah, negative infinity to infinity, right? So the domain here will be all reals. What's the range? See, while you're playing, it's funny. Like you said, 8 sideways. It'd be funny if you got on the exam. It's like, damn it, I can't remember the name. All I can remember is 8 sideways. That would be funny. Anyway, that would not be funny because if you got that question wrong, I'd be upset. I would take it personal. That's fine. But not really. I'm just being silly. Okay, what's the range? How far down does this graph go, right? So notice this graph stays flat the whole time. So then what's the very bottom to the very top? How far down does it go? How far up does it go? If it stays flat the whole time. Not 0. 0 is the x value. What's the y value? How far down? What's the y value? The y value in this case is going to be c, right? So the range here would be just the number c. We will use curly brackets. The curly brackets means just that number. It indicates or signifies a discrete set. Is this function increasing, decreasing, or constant over the domain? So as we trace it left to right, is it increasing, is it decreasing, or is it constant? Is it increasing, decreasing, or constant? It's constant, right? So as we trace it left to right, it stays flat the whole time. Is there any kind of symmetry here? Is there like y-axis symmetry or origin symmetry going on here? In general, do we have any kind of symmetry? So is there either y-axis symmetry or origin symmetry? So like if we were folded on the y-axis, would it match up? If we tried to, yeah, we do have y-axis symmetry, right? We can fold it on the y-axis and the right half is going to match the left half. So y-axis symmetry is the same as a function being even. And the definition of a function being even means if we do f of negative x, we get back the original. Okay? So this function is even, which means y-axis symmetry. So the domain is all reals. The range is just the number c, whatever c is. It's constant from negative infinity to infinity. So it's constant over the entire domain. It's an even function, which means we have y-axis symmetry. Can someone tell me the domain and range of this one? What's the domain? What's the very left to the very right? So I think the very left here, very left to the very right is going to be all reals. Same thing for the bottom. Okay. Thank you for that. I'll let them in. I tell them to keep trying. The very bottom to the very top is also all reals here. And make sure he's using the link that's in yeah, the right link or whatever. Okay, so the domain here, domain and range are both all reals, or negative infinity to infinity. Is this function, is it increasing, decreasing, or constant? So as we trace it left to right, what is it doing? This is increasing, right? As we trace it left to right, it's always going up. So we would say it's increasing over the entire domain. Is there any kind of symmetry, like x-axis, no, y-axis symmetry or origin symmetry? Is there any kind of symmetry? So yeah, this one definitely has origin symmetry, which means that the function is odd. The definition of a function being odd means when we do f of negative x, we get negative f of x. Right? So origin symmetry. Another way to visualize origin symmetry, if we put our thumb on the origin and we cut it along the x-axis and we rotate it 180 degrees, the top half is going to match the bottom half. Right? Whenever we have x comma y, we also have negative x comma negative y. Okay? We also have negative x comma negative y. Let's keep going. I think we said all those statements. Oh, you frozen? Oh, you are doing anything. Okay, let's go like this. Okay. So I think we made all of those statements. Can somebody tell me the domain of this one? The very left to the very right? Okay, so the very left to the very right here is going to be all real, so negative infinity to infinity. Can someone tell me the very bottom to the very top? How far down does it go? What's the lowest y value? Yeah, the lowest, it goes from 0 up, and what's the highest? Okay. Can we get a y value corresponding to 11? What about 15? Is it possible for y to be 15? What about, yeah, infinity, right? So it goes from 0 to infinity. It's okay. Okay. Can you tell me what kind of grouping symbol is 0 going to get? Will 0 get parentheses or will it get a square bracket? What do you think? Will it get parentheses or square bracket? Square bracket, right? So it's going to get a square bracket because we actually include 0. So not only does it get really close to 0, but y also becomes 0. So we can include 0. Tell me about increasing, decreasing, or constant. As we trace this graph left to right, tell me about over what part of the domain is the function increasing, decreasing, or constant. Okay. Part of it's increasing. What is it doing initially? So as we trace the graph from the far left, yeah, it's decreasing first and then it's increasing, right? So over what part of the domain is it decreasing? What's the far left? Over what part of the domain is it decreasing? So it's decreasing from x goes from negative infinity up until 0, right? So it's decreasing from negative infinity to 0. So the far left was negative infinity, and it stops decreasing here when x is 0. And then it's increasing from 0 to infinity, off in that direction. All right? So the further to the right we go, the higher the y value goes, right? Is there any kind of symmetry? Or, in other words, can you tell me whether this function is even, odd, or neither? Even, odd, or neither? This function even, odd, or neither? So we do have y-axis symmetry. So if we have y-axis symmetry, does that mean even? Does it mean odd? Or does that mean neither? So it's even, right? So y-axis symmetry means even. Again, the official definition of a function being even basically is if we do f of negative x, we get back the original, right? That's the definition of a function being even. F of negative x, we get back f of x. It also means we have y-axis symmetry. Okay, this is okay. We got our domain, range. We said decreasing, increasing. This is the cubing function. Can you tell me the domain and range here? Domain and range here. So like if we do the domain, right? What's the very left to the very right for the domain? How far left is this graph? So keep in mind, the arrows mean continue the pattern, and I'm going to tell you flat out, there are no asymptotes here. So is it possible for x to be -4? Right? Is it possible for us to do -4 to the power of 3? What about -10 to the power of 3? What about a negative a gazillion, if a gazillion is a real number, right? So the domain would be negative infinity to infinity. Can you tell me about the range? The very bottom to the very top. What's the range here? Same thing, right? Negative infinity to infinity. Oh, yeah. I don't know what that was. That was weird. That was complete. Anyway. Let's see. So we did the range. Okay, tell me about whether or not this function is increasing, decreasing, or constant. As we trace it left to right, what is it doing? As we trace it left to right, is it going up? Is it staying flat, or is it going down? Right? What is it doing? It's increasing, right? So we'll say that it's increasing over the entire domain. And is this function even, odd, or neither? Even, odd, or neither? Neither. Okay, I think it's pretty clear that it's not even, right? Even will be y-axis symmetry, so if we fold on the y-axis, I think it's clear that it's not going to match. But notice, if you put your thumb on the origin and take the top half and rotate it 180, they're going to match up. Odd, this function is actually odd. We have origin symmetry. So when origin symmetry, another way is like whenever we have x comma y, we also have negative x comma -1. My dog does a spacing thing, and it's like it totally like makes me anxious when she does that. And like either I'm thinking she needs to go outside. It's just so distracting. So it pulls my attention, and it just like is really irritating. But it's okay. I mean, I'm about to let her out. We got a good amount of time, almost an hour. But you know, she'll be fine. She's been doing good all day. So anyway, this function actually is odd. So again, the definition of odd means if we do f of negative x, we're going to get negative of the original, right? And this is an example. Whenever we have, like for instance, here we have 2 to 8. Well, it's off the chart. So basically, if we have 2, 8, we also have -2, -8, right? Right, and these points they're symmetric in regards to the origin, right? They're the same distance, and basically symmetric in regards to the origin. Okay. So the domain, the range, is increasing over the entire domain. And again, this function is odd, which means we have origin symmetry. Tell me about domain here. What's the domain? What's the very left to the very right? It's the very left to the very right. So the very left is negative infinity to infinity, right? No matter how far left we go, we can find the corresponding y, right? Even if we went way over here, we can still find the corresponding y. No matter how far right we go on the x-axis, we can find the corresponding y on the y-axis. So the domain here would be all reals, or negative infinity to infinity. Tell me about the range, the very bottom to the very top. What's the range here? I think she just has cabin fever too. She just needs to get outside. I gotta take her out. I think I'm gonna take her for a walk today, even though it's like raining. It's trying to rain. It's been raining. 0 to infinity, right? So the range being the very bottom to the very top, it goes from 0 to infinity. Okay, tell me about increasing, decreasing, or constant. Over what part of the domain is this function increasing, decreasing, or constant? As we trace it left to right. So as we trace it left to right, what is it doing initially? So as we trace it from the left to the right, initially it's decreasing, right? From the far left, it's decreasing over what part of the domain? So, okay, right? So from 0 to where? It's okay. You got your attendance credit. Okay, so the update on attendance, once you get your attendance credit, you're good for the day. I'm not even going to make a big deal about other stuff, right? I'm not going to make a big deal about it. So once you get your attendance credit, it's okay. So we say that this function is decreasing from negative infinity up to 0, and then it's increasing from 0 to infinity. All right. So really we're using like attendance like as a moment to like check in. But you know, I get the whole thing with the technology. I'm not going to make a big deal about it. The main thing is just check in on a daily basis. Check in with me at the start of class. And then just make sure to get your assignments via Pearson and Alex submitted, and then you should be fine. And I'm available if you have questions, right? So I'm just here to just kind of help you guys get through this. So if you have questions on assignments, I use Pearson because as you have questions, when you click on the Ask My Instructor, it sends me a screenshot of the very question you're working on. And then I'll pull it up, I'll load it to my device, and I make dedicated YouTube videos walking students through their questions, right? But a closed mouth don't get fed, right? So if you don't ask questions, if you don't say anything, I'm going to assume one or two things. Either you're okay or you're afraid to open your mouth, right? But again, a closed mouth don't get fed. So we gotta speak up if we need help, right? That's what we're here for. We're really just here to help you along the way. Okay, so we said it's decreasing from negative infinity to 0. It's increasing from 0 to infinity. Is this function even or odd? Is this function even or odd? It is even, right? We do have y-axis symmetry. If we were to do f of negative x, we're going to get back f of x. Okay, so I think we're good there. All right, and I think we have all that here. The square root function is like the top half of a sideways parabola. Can someone tell me the domain of this? What's the very left to the very right? How far left is this one? 0 to infinity. Tell me about the range. Okay, I'll accept that for the range as well. I'm pretty sure you meant that for the domain. But it actually holds for both, right? Both the domain and the range are 0 to infinity. What kind of grouping symbol is the 0 going to get in this case? Will 0 get a parentheses or will it get a square bracket? It's going to get a bracket because we include 0 in both cases, right? Not only do we get really, really close to 0, but we actually reach 0. We actually include it. So it's going to get a square bracket. What kind of symbol does infinity always get? Infinity always gets what symbol? Parentheses, right? Because we never reach infinity as human beings. Even though maybe a spiritual being having a human experience, as humans, we never reach infinity. Is there any kind of symmetry? Is this function even, odd, or neither? Any kind of symmetry here? Is it even, odd, or neither? Okay, it's neither. And as we trace it left to right, what is it doing? Is it increasing, decreasing, or constant? Is it increasing, decreasing, or constant? Increasing. Okay, this looks good. Okay. So hopefully we aren't reading. I think I caught a student reading ahead earlier. In this one, you want to just actually take the images as they come. Like hopefully we're not reading ahead, because then you're going to miss the whole point. Because then in application, we won't have anything to read, and so we'll be kind of missing on the whole point of it. We're going to just kind of let this one be for now. This is called a reciprocal function. The reciprocal function has two unique properties. It has this whole horizontal asymptote, which is the x-axis, and it has a vertical asymptote, which is the y-axis. So what that means is that in the long-term behavior, we get close to those axes, or to those asymptotes, but we typically don't cross them. Who else? I know he's coming back, so I'll go ahead and open up. It'll be fine. So, if we have those axes, can you tell me about the domain here? Okay, so if you have a question about something from Pearson, go ahead and click on the Ask My Instructor. If it's an exam question or something like that, then screenshot it and email it to me, right? And that's okay. I don't mind going through a few of those. But on the other questions, just use the Ask My Instructor and email it to me. And we're going to actually stop pretty soon on this topic. And we'll use the rest of the class to kind of do problem sets. So can someone tell me about the domain of this? So another way to visualize domain, if we were to take this image and smush it onto the x-axis, is there any x that's not accounted for? What are the possible x values that it can take on? So can someone tell me about the domain here? What's going to be the domain? Tell me about the domain. The very left to the very right. Is there any x value that's not defined? Okay. So if we're dealing with a rational function, right? What number cannot be in the denominator for a fraction? We cannot divide by what number? 0, right? We can't divide by 0. Notice when x is 0, we can't find the corresponding y, right? That's where the vertical asymptote is. So then we would say that the domain of this is basically going to be everything except 0. If we smush this onto the x-axis, every x is accounted for except for 0. Okay? Can you tell me about the range after that discussion? If we were to smush this onto the y-axis, tell me about the range. What are the possible values that y can take on? What are the possible values that y can take on? So this one is a similar discussion, right? If we were to smush this onto the y-axis, okay, it can take on everything. So for this one, actually, if we were to smush this onto the y-axis, remember we have a horizontal asymptote, which is the x-axis. So that means that y equals 0 is not included here as well. All right? So we're going to say this one is going to be everything except 0 as well. So the domain and range are the same. It's basically everything except 0 for both of these. Okay. Tell me about whether this function is increasing, decreasing, or constant. As we trace it left to right, it's kind of weird. I know I made this joke in my earlier class, but because it's so quiet and I'm just talking to the computer, it feels like I'm actually talking to the computer and the computer's actually thinking. It feels like I'm teaching the computer. It feels so weird. And I know you guys are there because, I know you're there, but it just feels weird because it's so quiet. It's just weird. But as we trace this graph left to right, what is it doing? Is it increasing, decreasing, or constant? Is it increasing, decreasing, or constant? As we trace it left to right. Is it increasing, decreasing, or constant? So this is actually decreasing over the entire domain, right? I tried to give you time. Once I see it, after I say it, I don't know. But yeah, this is decreasing over the entire domain, right? As we trace it left to right, it's always going down. It's going down. Is there any kind of symmetry? Is this function even, odd, or neither? Is this function even, odd, or neither? It is odd, right? So odd means if we do f of negative x, again, the definition of odd means if we do f, come on, if we do f of negative x, we get negative f of x, right? That's the definition of odd. Right, which is the same as origin symmetry. If we put our thumb on the origin and take the top half and rotate 180 degrees, it's going to match the bottom half, right? That's the reciprocal function. Increasing over the entire domain, it's an odd function, which is origin symmetry. Both the domain and range are the same, everything except 0. And this one, I think we did it earlier. Okay. Again, this is called the greatest integer function, and it looks like this, right? Whenever we have a decimal between two integers, we always take the integer to the left. If we're on the integer, then we take the integer itself, right? Okay. So if you had the notes open, this is a good time to not look ahead, right? Because it just, it's okay if you get it wrong, and you need to experience being wrong at some point so that you can learn how to process that kind of energy. Because as humans, again, we're not designed to always be right. And so if you're so afraid of being wrong, that's a whole nother thing within and of itself, is to learn how to be wrong and keep going. Really, as humans, really, we only fail when we stop trying. But every time we get something quote unquote wrong, it's not really wrong. We just successfully found another way that it's not going to work. As long as we keep going, eventually we'll get there, right? As long as we're alive and we keep going, we'll get there. But we really only fail when we stop trying. Right? So I say that to say, just kind of don't be afraid. It's okay to be wrong. Like, it's okay to make mistakes, and I don't want you guys to feel like you can't make a mistake. It's okay. That's our nature. That's our design. So tell me about the domain here. If we were to take this image and smush it onto the x-axis, is there any x that's not accounted for? All right, can you tell me about the domain? What are the possible values that x can take on? What are the possible values that x can take on? So the domain in this case is actually I'm intentionally trying to delay because I notice that answers like to come in right when I give the answer. All right. So the domain here is all reals, okay? Negative infinity to infinity. So with this, right, if we were to take the image and smush it, it looks like there might be gaps, but actually if you smush it onto the x-axis, there's a y for every x, right? Because it's everything kind of gets filled in. This fills this one in. This fills this in, so on and so on, right? So every x is accounted for. No matter what x you choose, you can find the corresponding y, right? But is the reverse true? Is every y accounted for? Right? If we were to take this image and smush it onto the y-axis, what do we notice is going on? Right? Like, is it defined for y equals 0? Well, yeah, y equals 0 is here. Notice we also have y equals 1, y equals 2, y equals 3. We could also do y equals 4, 5. Right? What kind of set am I describing here? What are these numbers? 0, 1, negative 1, 2. What? Negative 2. What are these numbers? What set is this? So if we were to actually smush this onto the y-axis, this would be the set of integers. Right? These would be the integers. Notice that like all the fractions and irrational y values, there's no corresponding x for those. So the output for the y's are the set of integers. On any given segment, is this function increasing, decreasing, or constant? On any given segment, is the function increasing, decreasing, or constant? Right? We would say that this function is constant on each segment, right? So we would say it's constant from 0 to 1, on the half interval from 0 to 1, half interval from 1 to 2, 2 to 3, So on the sum, we do ellipses in both directions. So we're saying continue this pattern, but it's basically constant on all of these segments. Any kind of symmetry, if you had to guess, is this function even, odd, or neither? If you had to guess, even, odd, or neither. Any kind of symmetry? If we fold it onto the y-axis, it's going to match up? No. If we rotate, if we were to put our thumb on the origin and rotate it 180 degrees, will they match up? Close, but no. They don't match up there either. So this one is no symmetry. So we would say it's neither even nor odd. The main is all reals. The range is a set of integers. And it's neither even nor odd. No symmetry. Okay? Alright. Let me make a note here. So I know we still got about 30 minutes. I'll keep you for maybe 20 minutes. Let's do like... Let me make a note. Let me see. So we're going to say stopped here. Today is what? Today is Thursday the 17th. Thursday, September 17th. That's out of 20. Okay, this was the 5 p.m. Sorry, this is the 5:15 today. And then tomorrow, we're going to start here. Friday. September, is it going to be 18? Yeah. September 18. I keep doing that. At 4 p.m. Okay. So we're not really done with class. What I wanted to do for the rest of the class for this next 20 or 30 minutes, we can use it as a study session and just to kind of put things in order, right? So if you have questions from the homework, now is the best time to ask it. If you have questions from like Alex, you can ask questions there as well, right? Let me go ahead and load a copy of this for you all to access for later, and we'll finish this on Friday. But for right now, let's just take some time to kind of go through the homework. Okay. So I'm really just here to kind of answer questions. Okay. And we can answer questions over anything if you want to talk about. Oh, okay, wait a minute. I was just about to get comfortable. I see there are requests. You said 13, 14, 17, and 18 on Pearson. What section does that come from? 1.4. Okay, let's look at section 1.4 from Pearson. I like this view. I could do it there, but I think sometimes it messes up. It does better when I'm over here. Let's go to Pearson. So I'm going to go to manage. Section 1.4. Let's see, let's preview. Okay, if I go back to the chat. Okay, let me take some notes here. I know you guys. Let me see. I mean, I guess I could do that. That'll be okay. I don't really want to do that though. Let's just go like this. Okay. So let me do it like this. Let me do paper, graph paper, and we're going to work the homework. So this is going to be section 1.4, a library of functions, library of functions, all right? And those are numbers. Mr. Robinson, what's your favorite? What color are you feeling? Wait, y'all are getting okay. What might be better? I mean, this will work. This is fine. So let's do 13, 14. I might alternate between these lists. 17, 18, and then there was also a request for 3, 10, 11 on this week's. So I'm thinking it's still 1.4, 11, and 22. So we might kind of jump around between these two sets. Okay, Mr. Robinson is blue, right? You said blue? Blue. Okay. Let's look at number 13. Let's go to number 13. I know you can't see it just yet. Give me a moment. 13 is here. Let f of x be this. Find these. Let me screenshot this. Screenshot like this. I'll pull this from there. I just want to copy. I just want to share. You're not going to let me copy? Let me just airdrop. Yeah, I'm not liking that at all. Okay, so let's hop back over here. I know what I can do. Alright. Oh, I'm doing that thing again. Okay, so this is the first one. This is number 13 from the homework. This is 13, right? It says, it might be a little blurry. We just have to do the best we can. And I'll go ahead and rewrite it. So it says, let f of x be equal to, it says x if x is greater than or equal to 2, and it's going to be equal to 2 if x is strictly less than 2. Okay, so then part A asks us to find f of 1. So if we're going to do, let's go like this. Okay. So if x is going to be 1, do we use the first line or do we use the second line? If x is 1, do we use the first line or do we use the second line? So 1, right? So it applies, x is less than 2, 1 is less than 2, so we're going to use this line. So this answer is just going to be 2. Okay. B asks for, oh, okay. So not only did it ask for f of 1, it also asked for f of 2. So if x is 2, do we use line 1 or do we use line 2? If x is 2, do we use line 1 or do we use line 2? Right? I think we use line 1. All right, because x is greater than or equal to 2, so we're going to use line 1. So then the answer is going to be x itself, which is just 2 in this case. Okay? Then it asks us to do f of 3. Do we use line 1 or line 2? 1 again, right? We use 1, and so x itself is going to be 3 in this case. And then part B asks us to sketch the graph. So this is like y equals x. It's just going to be a diagonal line. This is a flat horizontal line. Okay, so let's graph these, right? So we have a little bit of some simple graph paper. So y equals x is just a diagonal line, right? So here's positive x. Here's our positive y. So then we get an image. All right, we're going to go back and make a change. And let's do this first one. Let's do the first one in blue. So it can stand out a little bit better. Anybody want to give me another color for the second one? Anybody got a favorite color for the second one? Red. Okay, we can do red. Guys typically like to choose red. So the second one we're going to do is y equals 2. Let me see, y equals 2. I didn't number these, but basically the second one is 2. So this one, right? But then we need to go back, and we got to erase one part and get rid and keep the other. Okay, so now let me see. Let me go here. Okay. I think they both. Okay. So now with the blue says for the blue line, it says that applies when x is greater than or equal to 2, right? So if that applies when x is greater than or equal to 2, are we keeping the left part or are we keeping the right part? If x is greater than 2, are we keeping the left part or the right part? So again, the blue line says it applies if x is greater than or equal to 2. So do we keep the left or do we keep the right? Yeah, we actually keep the right, right? Because x is greater than or equal to 2. So those are all the numbers to the right. So we're going to get rid of the left. All right, just like that. Get rid of the left. Then the next one the red line says that applies when x is less than 2. So then for that one, do we keep the left part or do we keep the right part? So for the red line, do we keep the left or the right? We actually keep the left, right? So who's on first? Yes, this is on first. Yes is on first? No, who's on first? That's what I'm trying to ask you. You know, the whole Abbott and Costello routine? That's what it sounded like I just said when I said left, right, right, left, right. So yeah, anyway, it says x is less than. I'm totally sleepy and I'm totally like ready to get off the call and like go do other things. And but I'm happy to be talking about math. I really like it. But yeah, x is less than 2, so we're going to keep the left part, right? So we're going to get rid of the right. There it is again, right? But we got rid of the right. Now, normally, the red will be an open circle and the blue will be a closed circle, but because they overlap, then it just stays filled in. They like, one fills in the other one. All right, so then we get this image, right? So then, yeah, let's hop back over. So then if we go to Pearson, we said that f of 1, we said that was 2, so I'm going to put 2 and hit enter. F of 2 was 2, I'm going to hit enter. f of 3 is 3, and hit enter. And then which graph is it? It should be what? I think we got A, right? It's A. Okay. So the next one that was requested, let's go ahead and do question number 3 so we can alternate between these lists. So if we do question number 3, I keep forgetting that you guys can't see this, but they were all correct. Find the intervals over which the function is increasing, decreasing, or constant. Okay. All right, so let's do number 3. And number 3, it comes from section 1.4, question number 13. It says intervals for which this is increasing, decreasing, or constant. Right? And we have f of x equals 4x plus 2. Right? So this was the answer of the last one. Now ours is going to be different. Mine is going to be different than yours, right? Because it basically makes a new set of numbers each time. Okay. So we got these results for the last one. So this one says what? So okay, for instance, if there were a gap between the red and the blue, then the red would have gotten an open circle on the endpoint, and the blue would have gotten a closed circle. We use a closed circle when there's an equal to bar, and we use an open circle when there's no equal to bar. All right, but because one fills in the other, then we can just do it like this. Can somebody tell me the graph of this? We have f of x equals 4x plus 2. Can somebody tell me about the graph of this? How could we graph this? So this graph, let me do it like this. So this is the positive x, this is the positive y. Let me kind of do some labels. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the origin. 1, 2, 3, 4. Okay. Okay. So it's going to be a line, right? Let's do it in blue. So the y-intercept is 2, and then the slope is 4, right? So we will go up 1, 2, 3, 4. 1, 2, 3, 4. Our 4 actually kind of goes off a little bit. It goes to about here. Let's go the other direction. 2, 4, and back. So then we'll get an image kind of like this. So notice as we trace this graph from the left to the right, it's always going to be increasing, right? So we would say it's increasing over the entire domain. I think I'm going to just go ahead and let this be the last one. Let's go ahead and at least submit the answer. It's increasing. The function is never decreasing. It's never increasing. So it should be A. The function is increasing. Nope. It's never decreasing. The function is increasing over the entire axis, right? So I'm going to say from negative infinity, INF, up into infinity. Okay. So we got that one correct. Identify the intervals over which is constant. It's never constant. Okay, that was it on that one. Okay. So we were able to do a couple of questions today. I know we're kind of like out of time. Were there any? I'll go ahead and make it so that everybody can unmute themselves. But were there any burning questions that like anybody needed to ask other than homework help? If you need more assistance with the homework, try linking up with either your classmates or the tutors, and also make use of the Ask My Instructor. Right? Click on the Ask My Instructor, and I'll do dedicated YouTube videos walking students through examples.
Professor,
Go ahead.
I tried to put in the Alex code when you had emailed it to me, and it said that I was already in that class.
So you might already have an account. So then you have to click on Forgot Password. And usually,
no, like I got an account already and everything. Like I'm looking at my class list, but it only shows where I took the placement test at.
Yeah, that's fine. So just keep going wherever you left off.
Oh, okay.
Yeah, you just keep going wherever you left off. Okay, guys, if there aren't any other burning questions, I'm going to let everybody go. Okay? You guys were great. Thank you for being awesome. And I will see you all same place. Well, 4 o'clock tomorrow. All right? All right, guys. Enjoy the rest of your day. See you tomorrow.
You too.